No, good stuff. Well, I think we'll get things going here. I just want to welcome everybody. My name's Adam McFadden, the owner of Firehouse Training, and also a part of the team here at the Fire Mitigation Alliance. Super excited to present class here tonight. The free session on battery energy storage systems, tactics either for the firefighters in a group, emergency managers, insurance policymakers, policy holders as well. And anyone in the general public or community safety area, either aspiring to have a career in that section, in that sector, or also currently working in it. We do have some of our workplace safety sales team as well here from Firehouse, and then a few others from the workplace industry that have a general interest in this topic. So really looking forward to presenting that. Again, we have Justin Brunner here from Desasolve and the Fire Mitigation Alliance. Peter as well, Peter Sells from Fire Rain, Tom Hockett. And for the next hour or so, we're just going to go through some different scenarios and different industry best practices when dealing with large urban area battery energy storage systems. So a little bit about who we are with the Fire Mitigation Alliance. We're a group of companies that have come together to support the growth in training, education, preparedness, and even equipment when it comes to emergency services and workplace safety. So with companies like Fire Rain and EcoGel, Desasolve AI training platform, Amplicam wildfire sensor technology, and my company Firehouse Training, we've had the ability to co-promote and also bring awareness to different solutions in the industry that otherwise many people didn't know that we had. And that's one of the reasons why we did form this alliance. Just a couple of housekeeping issues as well. If you can, please put your email in the chat. Justin and I are going to send out some information to you further following this training. Also, we are running a summer event. Once a year, we have been running a in-person event. It is free. We'll be doing that in Mississauga, probably June or July. And we'll stick probably to the battery topics, community and public safety, emergency management. We try to teach and provide training in more of a higher level content than just boots on the ground fire department, law enforcement, and EMS tactics. So looking forward to that. We'll put you on our email list specific for that event. And again, it's fun. We do some networking. You'll have a chance, if you're an aspiring firefighter, to meet some chiefs and others in the industry. If you're in the insurance industry, you can come and meet some, public safety experts. If you're interested in more about a specific topic, whether it's batteries or hazmat, you can have the chance to deal with both public agencies and private industry through the Mitigation Alliance. So we do like to network and have a bit of fun. And then, of course, we'll have some drinks and dinner after, and hopefully Tom will pick up the tab. But with that being said, Tom, you want to introduce yourself and talk a bit about the Alliance?
Yeah, thanks, Adam. Yeah, I'm Tom Hockett. I'm the sort of the president of the Fire Mitigation Alliance. I'm the guy in this group that has not actually fought a fire. I guess putting out a bonfire may count, but I'm not to say no in this world. But I come to this world from the wildfire mitigation side of things, using technology to detect wildfire, early predictions. The whole idea of we can save money by actually getting at these wildfires before they get out of control. That's my raison d'etre. And just I'd add to the summer event, what's great about those live events is Adam really can show off some of the products live. You can touch and feel them. Not necessarily actually shoot them off or anything, but at least you can touch and feel them anyways.
No, it makes a big difference for sure. I appreciate that, Tom. Justin Brunner, yourself?
Yeah, actually, that's a great idea, Tom. Maybe we should actually burn some stuff at them. You think they would enjoy that at the facility there?
I can throw my little 1650 battery right now as hard as I can on my computer screen. We'll see what happens. How's that
sound? Anybody know any firefighters that we can have on site for that? Justin Brunner, CEO and founder of Desasolve. We've created a platform where we use performance engineered AI systems to bring our training expertise to complex, uncertain, and dynamic environments. And, this really enables organizations to train, develop, and scale consistently and efficiently with all the training that they do. We have a large focus inside of emergency services, working with fire departments and moving out to both EMS and law enforcement as well.
Nice. So we're going to have a scenario at the end. We're going to put some of this training to use. There's no sense to just do a death by PowerPoint without putting a live scenario in place. So we'll do that with the last 15 minutes of tonight's session. So looking forward to seeing what everybody picks up and hearing about the expertise in the group. Mr. Sells, Peter Sells.
Yeah, hi, everybody. I'm Peter Sells. I'm one of the founders of FireRain. My background, I was Chief Training Officer, Toronto Fire, when I retired, which is quite some time ago now. And I did not train Adam. I'll point that out right now.
Uh-oh.
I disavow any knowledge. But we produce the world's only 100% bio-based fire suppression hydrogel.
Love it.
I'll tell you a little bit more about it a little bit later on. Yeah, so that's what I'm doing now, as well as consulting internationally on training and fire department management.
Good stuff. So we'll jump right in, everybody. So again, in the next hour or so, this is a snapshot of a lot of content that we presented. Myself personally, I've had the chance to teach, lithium-ion battery, electric vehicle training, dealing with battery energy storage systems and other aspects of these spicy little batteries, not just across Canada, but across the U.S. as well, from Miami to Oklahoma, Michigan to Massachusetts. So in the next 2 weeks, I'm actually going to be doing some classes in Massachusetts and even in Indiana. So lots of great opportunities to bring all this content together. So the one thing I will say is reach out to Justin, Tom, Peter, myself after the fact if you're looking for more information. We have a lot of different backgrounds here today. We got, Greg Scott, retired military fire personnel. We got Chris Gilbert, former resident of Canada, now chief emergency manager up in the in the Florida area, right? So again, we got lots of amazing individuals that are here. So please ask questions, get involved. If you can't turn on your videos, hopefully many of you are fully clothed. Feel free to get involved because I do like to have good discussions. There's 10 different ways to skin a cat when it comes to dealing with batteries. We'll talk about that today. So when it comes to these energy storage systems, there's a rapid growth. We're seeing these pop up in Muskoka, in Northern Ontario, Southern Ontario, increasing use and grid stabilization of these renewables, right? And the push for green energy, no matter what side of the political aisle you're on, right now there is a big push for this green energy and renewable sources. We know, however, as the first responders here in the group, there's a unique fire and explosion and toxic risk. These are not normal fires. These are chemical fires, and we'll get into that shortly. The limited real-world response experience that many fire departments have, many that I train, including career departments, as respectfully as I'll say this, really have no clue on what they're going to do to deal with these fires. They've never seen anything like it, and even awareness level training sometimes isn't enough to understand if they have the resources to deal with it. Do you need foams? Do you need an eco gel? Do you have enough water? Is it worth putting firefighters at risk in the isolation area or the hot zone, breathing this toxic gas in or being in the area of that toxic gas? So as we talk about these things, again, we need to understand this is a different event. So the critical need for awareness, and not just fire, but even us hazmat geeks and other industry sectors need to know what is happening with these fires. This is a hazmat fire. So improving safety, having better response tactics, and even risk reduction is huge. When you look at things like higher fire loads, think about things like synthetic materials. It seems like everything's made of plastic these days. Now you get into EVs, e-bikes, battery energy storage systems, even the threats on the environment. Think about this, for example. The battery energy storage system that's on fire, the amount of water that is going to be put in that area to even try to mitigate that event will cause so much environmental harm like we've never seen before. The corrosivity that comes from the runoff from these fires is very, very serious, and I've seen it firsthand. We had more hazmat calls after one particular factory fire in a 2-week span than we did the night that fire encompassed an entire automotive solvent warehouse because of the environmental impact. So we see that. So aging infrastructure, vulnerable populations, we know that all that will go hand in hand with the fact that we're building these large battery boxes and battery energy storage systems in areas to have off-peak hour energy, extra energy when we need it. Now, when you're looking at things like pre-incident planning, right? Or my good friend Brent Brooks from High Rise Firefighting says it best. We need fire attack planning. What are you doing for site walkthroughs, utilities, systems? Do you have partnerships with local property managers and builders, fabricators? Is there community evacuation plans that have been communicated? Is there, I say high-rise considerations there, but again, industrial considerations, standpipes, large area water supply, isolation perimeters, tying into the municipal water source. All these things as first responders, as community emergency managers and others, we need to have an idea about it. A quick story. I did some work at a military base just in Eastern Ontario, just doing some general battery and hazmat safety training. When we realized that they were building a large battery energy storage system that was tied in with a major transformer from the local solar farm that was nearby, we realized that the local fire department had no idea about the hazards and risks. In fact, they didn't know that because of budgets, there was not an adequate ventilation system in that battery energy storage system or an adequate standpipe to even apply water on the inside of that battery box. The fire department had no idea. The only reason they found out about it was from me, because I was there on site doing some battery training, and I knew a couple people in the local fire department. So when you see this gap, we just want to make sure that we do have an understanding that, you know, it's incumbent of all of us to really have a good idea what's going on. Chris Gilbert, I see you sitting there. I might put you on the spot, my friend, former Thunder Bay native down in the nice warm state of Florida. From an emergency management standpoint, are you seeing these pop up in your area, Chris? And have you had much oversight, even in your role working for the state?
The one benefit is we coordinated with the building departments for the permits, and even now with Tesla Powerwalls and all the rest of that going into residential and commercial, we're getting approval and sign-offs to make sure that the panels as well as the meters are marked to indicate that there is secondary and tertiary power supplies, because if you pull the meter out, you're still energized.
And again, someone like you would know that, but do you think that the average, let's say, volunteer or rural fire department, would they know some of those things?
Oh, you got to get the information out there, because that's the loss, even for your full-time fire departments and that. There's a ton of firefighters that, you know, you mentioned best, and they're going to look at you with a deer in the headlights look.
So again, you know, that's just a whole process, and I appreciate that feedback, Chris. The NFPA 855 is a standard for these storage systems, and I'm not going to go through it all tonight. And in fact, we could probably write a book about it. But when you look at the information on the slide, what is the best system? Designed to store and discharge energy, found in containers, buildings, and outdoor installations. Large commercial units have batteries, inverters, HVAC systems, BMS, battery management systems. But when I look at it from a first responder standpoint, emergency management, I printed it off today. What are the key considerations of NFPA 855? Well, let's go through it. Choice of site location, emergency response planning with local fire departments, and detailed response protocols required to fight a fire. Ventilation and gas detection, right? Does your local fire department know how to use their little 4 or 5 gas meter or even a PID? Fire suppression options, automatic fire suppression systems, and working with the local fire department to utilize those systems. Thermal runaway mitigation, and like Chris said, like shutting things off or pulling meters. Spill containment for environmental hazards, electrical isolation, community evacuation planning. Do you protect in place or evacuate? We're going to talk about that in a little bit, because that's a huge decision. And then the overall environmental impact. Those are the points from NFPA 855, which outlines the standard. And I can tell you right now, from an emergency management standpoint or fire department standpoint, we do not get the training on that. It's scary. Greg Scott, I might put you on the spot. With your background in hazmat and obviously seeing this pop up and being a fellow battery trainer, are you seeing more of a communication about these hazards to your fire students, for example, the local college, or even some of the fire departments you've worked with? Do you still think that it's an uphill battle?
Well, it's definitely an uphill battle. Like just you said, just working at the college, they have 2 huge BESS systems that power the college during the day. They run about 2.6 to 2.3 kilowatt hours per hour into the building to power the school, and at night they re-energize them off the main transformer. So these are right on the property of the college. So, the local fire service, I think they have an understanding of it, but again, it's backed right onto a residential center plus within vicinity of all the residents, the college residents. So how are you going to evacuate that area or shelter in place based on the wind or your plume modeling, right? So it's an interesting battle, to say the least.
And I like what Greg said, and we'll talk about this later in Justin's scenario. Plume modeling, understanding what the risks are. This is a corrosive and toxic gas. Depending on who you ask, or if you watch my buddy Patrick Durham at Stash Training, again, amazing YouTube channel on battery fires and battery mitigation. You got my buddy Chris Fapp at Hazmat Rescue. He should be here tonight. Not sure where he's at. But these guys will all tell you, depending on who you're talking to, well, this battery is safer than the other battery. So if you look at some of the hazards of the different chemistries, and I'll keep this simple for tonight. Lithium iron phosphate. A majority of the BESS systems are these lithium iron phosphate, which is supposed to be a more stable and safer battery. Not necessarily. Once it goes boom and woof, it's going to be spicy. It's going to be high heat. There's still going to be the corrosive byproducts of combustion, like hydrofluoric gas that comes off these batteries. Then you look at NMC, nickel, manganese, cobalt, a higher energy. They're highly volatile, and they're a little bit more excitable when they're heating up, when they're on fire. They're both still bad when they burn. But just a quick example, your LFP, for example, when I'm doing some training at airports, is your ground support equipment. A lot of them use that. Apparently, that type of battery chemistry is a little bit more stable and high versus high heat versus cold temperatures. But again, you have to do your own research, everybody. There's pros and cons to all of these batteries. They're all a little bit different. What is thermal runaway? Greg, I might put you on the spot again, pal. When we get into thermal runaway, a damaged battery, what's the best way to describe because we do have a lot of non-firefighters here tonight, so we got to keep that in mind. What would be the best way to describe what the heck happens when you have one of these batteries going into thermal runaway? How's it different than a normal campfire?
It's like a short circuit.
Yeah.
So with that, the dam, I guess you want to call it, inside between
your
the two different.
separator,
Between the anode and the cathode. If that fails, that product's going to short circuit, and then it's going to react and cause a lot of issue and rapid change of temperature and get that fuel going. And it's ongoing. So it's not going to stop. And you can cool it, but it's going to either have to burn itself out or, move the cells around.
So that's the thing with these batteries, with all the different metals inside, right? Nickel, manganese, cobalt, a liquid lithium, otherwise known as an electrolyte. When these batteries start to go into thermal runaway, it's like shaking up a Dr. Pepper bottle and the pressure builds up inside, okay? So with my 18650 battery here, okay? When the pressure builds up, it just pops. Now, unfortunately, I've had a few circumstances in my last shift just a couple of weeks ago before I went on vacation. Three battery calls that day, 2 e-bike fires and a cell phone. We run out of battery buckets. We go through so many of these. We talk about the containment side of the business. So when you look at the risk, why do you think we're seeing more battery fires now than we ever did before? Anybody want to put that in the chat or speak up on video? What do you think? Why are we seeing more battery fires than we have in recent years?
Less standards, cheaper chargers.
You got it. Where are they coming from? They're coming from Amazon. They're coming from good old Temu. All these websites
from overseas,
coming over from China, right?
Like the
and
quality
the
standards
isn't there.
The standards in North America are such a high standard as opposed to over in south of us. We're getting all this crap coming from overseas, and like you look at, there's no ULC, there's no CAN, all that standards we have to follow here, and they just stamp it here.
A lot of them are taking the UL certification markings on them, so you can't tell the difference.
Yeah. Like my good old battery rack here from China, right? One of the drone companies I worked with gave me these, and they couldn't promise the condition they were in, but they looked okay at the time. They've seen better days since they've been banging around the back of my truck, but that's another story. So with these batteries, though, keep in mind, my buddy Bobby and Mike at the Hazmat guys said it best. They've never seen one battery burn the same every time, and they've seen tons of battery testing because the proprietary nature of these things is always going to be different. A company wants to save money because there isn't enough nickel that they can get for their manufacturing. or maybe they want some more manganese or a little bit less lithium or electrolyte in their battery because it's safer or more cost effective. There's many different reasons why they change the chemistry from company to company. GM to Tesla to the new Chinese EVs coming to Canada to Rivians. Like there's many different models. So when you look at the hazards to first responders, understand some key things. Highly toxic, highly corrosive. The explosion risk is real. Before the battery typically catch fire, you're going to see a white smoke. That white toxic gas is an HF, hydrofluoric acid gas. And depending on how close you get, it might even smell like cherry bubble gum. So keep in mind the smell, the smoke, the other things that we see, including the physical damage that you might see to the outside of that battery module, they call it, or cell, whatever you're looking at. It plays a serious risk, and we just need to be aware of that. Tonight, we want to talk about these risk assessments. Now, Justin, I might ask you, you've been following quite closely the importance of understanding thermal dynamics and thermal management. Why do you think it's so important to use tools on your truck? What tool do you have, because of some of the extra training you've done in recent years, that you look more closely upon to find out more about a battery's condition?
Yeah, we're spending a lot of time, the first thing off the truck with any of those vehicles or anything with these batteries, right? First tool we go to is our TIC for that, our thermal imaging camera.
Oh, yeah.
Right? There's a lot of things you got to be mindful of when using any of these tools, but it is definitely one of the things that gives you insights into what's happening in and around those batteries in terms of how the heat transfer is working, where things are moving to, and really what's going on. And it gives you early insights as well as you can see temperature change and things like that. So it definitely a useful tool to have with you and should be one of the first things off any truck as you respond to these things, and having them with you even going interior and afterwards during overhaul, right? That's a big thing with laptops and phones and everything else that we have in houses, right? We need to be checking those things as well.
When you're looking at thermal cameras, oh, sorry, someone's going to say something?
Yeah, Adam, can you comment on, is there any way to tell the amount of fuel or energy that's in these batteries? Because you've said that the amount of how long it's going to burn and how, I don't know about the ferocity of it, but is based on how much power is stored in that battery at that time. Is there any way to know?
Great point. So first thing you want to do when you arrive on scene, ideally, is ask, what is the state of charge? So the state of charge is incumbent on how spicy these batteries are going to get. If it's fully charged, that means it has a lot of energy and volume that it's going to burn for a long, long time and probably have a little bit more excitement than maybe something with a 20 or 30% state of charge. So that's a question that you want to ask typically, whether it's an electric vehicle, a battery energy storage event, or other things that you're dealing with those batteries. The overall amount of time that it's maybe been on a charger. Like here's one thing you need to know, everybody, is that whether it's an e-bike, electric vehicle, it doesn't need to be on a charger to go into thermal runaway. In fact, studies are showing it's the other way around. Based on the physical damage, based on the internal corrosion or dendrite growth, we call it, we might see this battery going to thermal runaway at any time. We've seen that in the hurricanes from Hawaii to Florida to even the wildfires in California. Chris, do you want to talk a bit about just some of the phenomenon stories you've heard in your neck of the woods, where months later these batteries will get spicy and catch fire because of their overall condition? Is there any stories from down in Florida from that?
During the hurricanes 2 years ago, especially down on the Gulf Coast, a lot of the problems we're having with flooding, and again, vehicles just spontaneously going into thermal runaway, but others that came out of the area and were sitting for months, and then all of a sudden sitting in a tow company's yard, and that waiting for an assurance adjuster to say that yes, we're writing that Tesla or Rivian or whatever off, and it spontaneously goes into a thermal runaway. And this is the problem. We've had a Tesla that was involved in an accident here that was shipped out to California, and almost a year to the day of the accident, it spontaneously went into thermal runaway. And even Hawaii with the wildfires, even after all of these vessels were burned and all the rest of that, they still held a charge, which is the other concern you got to be worried about.
Chris is right. Ladies and gentlemen, just because they look burnt out, if that cell was entirely burnt out, does not mean there's not still a charge or energy left in it to cause further fire if there is another ignition source or it self-ignites again, right? And that's huge. You look at Moss Landing, the world's largest battery energy storage facility that caught fire in California, multiple incidents of overheating within 1 or 2 cells that caused that propagation of the entire rack, right? Like I'm showing here. Hopefully it doesn't go into thermal runaway tonight when I'm sleeping. But what I'm saying is with this rack, you need to remember when one cell goes into thermal runaway, it will impact all the rest. And basically, it becomes impossible to control. The smoke plumes and the gas that builds up is like nothing else. So one thing I want to say, and again, shout out to Patrick Duro, my good friend at Stash Training. He says it best in a video. The companies that manufacture and fabricate these battery energy storage systems, from an engineering standpoint, and he can say this because he is an engineer, is the manufacturers are clueless. They're underpowered when it comes to clean agents, fire, and water supply that they have to even put out fires inside these boxes. The ventilation is not adequate to ventilate enough of the toxic gas and the buildup of that explosive gas on the inside to safely handle that too. Now, there is self-igniters in a lot of these battery energy storage systems that will not punch out, but basically burn off the small amounts of gas that might build up. That's a safety feature right from day one. But it's not enough to keep up when you have multiple cells going to thermal runaway. So I want you to ask yourself this as a group, and maybe I want Chris's opinion on this too after, because when you have a fire that big, and we know the gas is toxic, we have the hydrofluoric, we have the carbon monoxide, we've got all the other bad stuff that comes off of these burning metals inside these cells. Should we protect in place or should we evacuate? Because that's a decision that a fire chief needs to make, an emergency manager needs to make, and others. Because if you say, oh, we're going to evacuate the area, when you have that much toxic smoke in the air, is that really the best decision? And Chris Pfaff and I from Hazmat and Rescue had a chance to do some training in Michigan. We got our Hazmat Safety Officer training course a few years ago, and we spent an entire afternoon. I didn't think it'd be that exciting, but it was interesting to hear the other aspect. What is the acute exposure guidelines or smoke that someone is allowed to actually inhale safely? We call that the threshold limit, where they should evacuate or protect in place. And you know what? None of us in the room had an answer. And if you don't have an answer, I just want all the emergency managers here tonight in the room to think about the fact you're putting the community at risk. Because you don't know
sheltering in place. Yep,
well,
shelter in place.
And sheltering in place is the name of the game when thinking about, these kind of issues. I'm going to go through just some industry best practices here. And again, shout outs to many that I've had the chance to learn from various hazmat conferences and firefighting conferences across the U.S. We need to look at different situations. Letting it burn may be an option, but we also might need to cool adjacent battery energy storage systems so they don't cascade into one another and cause a larger fire and more toxic smoke. Do you have enough water? Can we use foam? Foam is not ideal for this. We'll get to that a little bit when we're talking with our friend Peter Sells. Do we look at possibly still using water supply for a vapor dispersion? Can we throw enough water and fog patterns from our ground monitors or maybe an aerial apparatus to bring the dangerous toxic smoke to the ground to at least get rid of the smoke if we're not going to fight the fire? The reason I'm bringing that up as a possible tactic is if you have a good water supply and if you want to protect the community next door. Water curtains and fog streams could be an option. My good friends at Modus, we use the spinny Bresnan nozzle to help cool adjacent exposures from bringing them down from a vertical setting. So ground monitors, I'm a big fan. Blitz fires, you use all the power you can, but remember, you're ideally going to cool exposures if you can get that power shut off. If you can't get a power shut off, even though lithium-ion batteries are not water reactive, they're not water reactive. It's not electrical, right? You're looking at energy, you're looking at voltage, you're looking at that stranded energy that we're trying to cool and mitigate. The electrical shock aspect isn't there unless you can shut off the electrical grid going into the battery energy storage box, is the best way to describe it. You just got to make sure it's shut off. So when you look at again, I'm giving industry best practices here from Surprise, Arizona, Moss Park in California. Decisions regarding tactics. Do you have enough water? Do you not have enough water? Do we need to control smoke? Do we need to protect exposures? The one thing we learned from the Surprise, Arizona event is that the ventilation and the smoke builds up in these battery boxes for a great period of time. Well, how long? We know that the firefighters in Surprise, Arizona made entry 4 hours after they assumed that fire was out. Even if the fire was out or smoldering at that point, they still were injured after 4 hours from making entry because of an explosion. And we'll get into that in a little bit. It's not a backdraft like you think. It's something a little bit different. Now, the reason I'm explaining that is because right now, currently industry best practices, and Chris Gilbert, if you know anything else or others, this is information I got from Mike and Bobby and the Hazmat guys and a few others, is you don't even want to consider making entry for a minimum of 48 hours, almost 2 days. Because the pressure from the smoke and the highly flammable and volatile smoke, which is highly explosive, takes so long in these boxes to actually decompress that if you were to open one of those doors to have to make entry in some of the models where you have to actually go in to view a battery pack or a module, an explosion will occur. Any thoughts on that, Chris, from the time? I mean, you've probably heard this before. 4 hours on scene seems a lot of time for like Surprise, Arizona. But it's not. It doesn't seem like a lot of time when you're on scene. We know we need to be there for longer.
You got to remember that, as each of those battery packs that are slid in there and that into the trays and that, it's just migrating from one to the other. So again, one goes off, then it's, 20, 30 minutes, another one's going off. And again, over your 4 hours, you're just adding to the entire thing.
This is
and
just
so it could be, days, like you say, 48 hours, and again, these are 53-foot size, trailers full of, batteries and that. I got to tour the Duke Energy one we have, which is a 2 megawatt, and got to touch the actual, cells that are slid in and then interconnected and then connected to the grid. And yeah, each one's about 45 pounds and that. And again, it's just racks upon racks of, lithium power packs.
Quick story here before we tee Peter up for a slide. We had an event, 2:00 in the morning, battery energy system alarm condition in our city in Toronto. We showed up. It was a Rogers infrastructure BESS storage unit. And when we got there, there was 3 individuals from Rogers on the outside, which was surprising. Because if you know anything about an industrial event, fire alarm systems, things like that, people like that usually run the company or work for that building, usually go in and want to take a peek for themselves what it is. What I found alarming, no pun intended, is that they were on the outside and they did not even go in. They saw the alarm condition and said, no, we're going to wait for the fire department to go in. I was very surprised. So we knew on the way there when we had alarm conditions there, I said to them, when we got there, I go, what could it be? Like, oh, it's a brand new system. We have no idea. That's why we didn't go in. So they couldn't even troubleshoot their own potential false alarm because they haven't had a false alarm yet. We packed right up. We went in, packed up, stretched a line just to say that we had a line, and went in and investigated. Now, it was just an alarm condition for an overheated module or inverter or something like that. But the fact that they didn't make entry speaks volumes, everybody, about how serious they take it. They're not going in without a mask on because they know the risks. Peter, what are your thoughts with your current product now? I know your white paper came back, correct me if I'm wrong, about the fact that your particular product, EcoGel, will have an effect on some of these cells and even an event like this. You want to chat a bit about what's happening in the product world?
Yeah, sure. Can you just jump back to your previous slide for 1 second?
Yep.
Okay, you see, and we've seen in several of these photographs that these installations will tend to be, lined up like soldiers, right?
Yeah.
Rank and file, and usually with some spacing in between them. And the overall strategy in an incident like this is to isolate and protect exposures.
Definitely.
Because Once that sucker has got going to this extent, that entire unit there, that entire piece is gone, right? There's no value to save there. What you're trying to do is save the adjacent structures on either side and up and down, and avoid propagation of that loss. So now, in that vein, if you could go back to where we're at. So let me explain what is being tested here. This was a study called the Innovation Solutions Canada project that we participated in on behalf of the Canadian Navy. And these tests were done at University of Waterloo. So in the photo on the extreme left, you'll see there's like a cinder block bunker.
Yeah.
And that black square right in the very center, that is a section of metal that is exactly the same as the bulkheads on a Canadian Navy vessel, with the same paint, the same metal.
Yeah.
And we destroyed a number of them. If you see on the top right and bottom right of that photograph, you'll see some monitors, like little cameras.
Yeah.
Those are actually thermal cameras. Now there's two more on the other side, and it's the other side where everything takes place. The second photograph, where the fire is burning, shows what the active test actually was, which was a pan of a metered amount of flammable liquid that was allowed to burn and expose that bulkhead.
Okay.
On the opposite side, what's going on is different agents are being applied to the opposite side of the bulkhead with the 10-liter fire extinguisher, with the intent to keep the temperature below 95 degrees Celsius. That specific temperature is chosen because that's the temperature at which the paint on the bulkheads will actually boil and start to burn. So in order to keep the fire from propagating through the bulkhead, you have to keep that exposed bulkhead on the opposite side cooled to below 95 degrees Celsius. So we did this with water and with our hydrogel, EcoGel, at 3 different concentrations, 1, 3, and 6%. And the results were that essentially the water was exhausted. It never did bring the temperature down below 95, and the water was exhausted before the fuel stopped burning. And you can see on the lower graph, the temperature at the end of the fuel burn with the water was 350 Celsius. So it was like raging hot on the opposite side.
Wow. Okay.
But with the EcoGel, the 6% didn't quite work as well. That was an application problem. 6% in an extinguisher isn't ideal. It's too thick for the extinguisher.
Yeah,
but at 3% and 1%, especially at 3%, we were able to keep the temperature of the bulkhead below 95 degrees, up to and beyond the point where the fuel load was exhausted. So what this shows is that EcoGel applied to the outside of a compartment, where the fire is burning on the inside of the compartment, will maintain that compartment to a manageable temperature. And then if you're also applying gel as a protective measure to the exposures on either side, then you are isolating the incident to the compartment of origin, as well as protecting the potential exposed structures on either end. So that's what we did with the Canadian Navy, and I hope to have more news about that for you later this year. federal budgets move at the approximate speed of continental drift.
Yeah, snail's pace.
Yeah. So, these tests are very positive for us.
No, this is huge. And one thing I do want to mention, right? And Chris can probably speak to this, Greg, of course, and others in the industry. Like I'm trying to keep it as politically correct as I can. It's cool to say that nothing can put out a battery fire, right? There's some great products out there. There really is. LiftX fire extinguishers. You know, we got the fire blankets. You have other options, and we just want to be cautious, especially for those here on the chat tonight, that you know you have to do your own research, because there's some great products out here like EcoGel and others that have white papers that have been tested at various universities and others that will mitigate and have an effect on these battery fires. Now, whether it's applied to the cell, whether it's applied to the module, whether it needs to be impacted inside of the cell or inside of a module, there's many different application types that can occur. But I just want everybody to understand that you know there are some great products out here like this, and we need to keep an open mind, because when people say, well, there's nothing we can do about lithium-ion battery fires and we have to let it burn, or you know, no products will work, you know, water won't put it out. We know more now than we did 6 months ago. We know more now than we did 12 to 16 months ago. And with experts like Chris Gilbert in Florida, spending time with him, and Bobby and Mike and the Hazmat guys, and Patrick Durham, and Chris Pfaff, and Greg Scott, and everyone else that's here that's learning as much as they can about this topic. There are ways to mitigate these fires. I'm not going to sit here and
toolbox,
say
Adam.
Tools in the toolbox, and we need to throw everything but the kitchen sink at these. And if you guys want something humorous, again, shameless plug, go to my TikTok, go to my Instagram, watch some of the videos of me teaching people how to use the undercarriage nozzles, right, to cool batteries, to cool and mitigate certain electric vehicle fires. There's more to it than that 15-second clip. Greg Scott's one of my co-instructors. We go through very detailed reps and sets on using HF paper, hydrofluoric paper to test the environment, pH paper to test the environment as well, thermal imaging cameras to look at different areas of that battery before choosing a tactic, air monitoring the areas, not just using a thermal imaging camera, but using a heat gun in a more direct rate to see where the heat might be propagating from, which could give us a little bit different information than that of a thermal imaging camera, which gives us more of a range. So, you know, Greg, myself, Chris, and others who've been to many of these conferences can give you 10 different ways to do a proper risk assessment before applying an EcoGel, before applying water. So I just want everyone to really keep an open mind, because whether it's your local volunteer fire department, your property manager, respectfully, I've gotten calls from major companies that are calling Little Old Firehouse Training and Desasolve and the Fire Mitigation Alliance and others, and Peter at FireRain, who want answers on what they're going to do to deal with battery fires. And they're building the batteries, and they're manufacturing aeronautical equipment and others, which is wild to me. So again, respectfully, we have some amazing people here in the chat, and that's part of the reason why I like to have this networking, is that if you have questions after this, send us an email and we'll get you in touch with a Chris, we'll get you in touch with a Greg, we'll get you in touch with a Justin, because there's so much going on here. Surprise, Arizona. Again, I highly recommend you research this yourself. I'll make it.
Adam, I'd like to just add one point.
Go ahead, Peter.
I agree with everything you just said.
Yep.
With a BESS system, with a BESS installation.
Yes.
Any fire that's going on inside one of those boxes really requires a engineered solution that was designed at installation.
Good point.
You really, all you're going to be able to do as a responder is deal with it from the outside.
Yeah, no, and you're right, because of that risk assessment, making entry, using tools like even your fantastic product. It's about the application and getting it where it needs to go. That puts the first responders at risk. So I agree with you on that. That's a good point.
Hey, Adam, from a preventative sort of situational kind of scenario, the pictures you're showing, these battery complexes are not indoors. They're standing alone or close to others, but still they're in an exterior environment. What recommendations would you have for industrial battery placement, and even charging units, and just the location issues? Because you've mentioned basements on previous times that hey, even leaving your tools in the basement's not a good idea.
You know what? And I'll be honest, I mean, that's kind of a whole conversation in itself. Tom, when you and myself and Justin and Peter, we all did our free event last summer, the hour training we did that night live in Mississauga was strictly on battery charging stations and electric vehicles in underground parking garages. We know that that's an issue right now. We know there's a huge risk. Speaking about the, we see a lot of exterior pictures tonight. You're right. When I went to the Regina airport to do some battery training out there just last year, they had a brand new battery energy storage, aka networking and infrastructure room built in the infrastructure of that airport, and they didn't even know about it. They heard about it, and when the chief said, yeah, it's been built about 3 months ago, but with the company that installed it didn't give us any awareness level training. So we went and we did our training ourselves. We found out about the FM200 system, which pros and cons on how that's going to work in that type of environment, to the other clean agent options that were already there to potentially extinguish a fire, the ventilation systems in place, the emergency shutoffs, all the things that a first responder needs to know. But as far as your question, Tom, like where these battery boxes should be located, the charging stations, the infrastructure, there's city councils right now from Sarnia to Ottawa fighting about this as we speak. I got phone calls from departments down south of Sarnia to north of Muskoka right now who are currently wondering who they should talk to get the best advice on if they should have a battery energy storage system placed in their community and where it should be placed. In fact, California, the fire department out there is one of the only fire departments that I know of who did a cease and desist letter to their own city saying, do not install this battery energy storage system right beside our fire station. My buddy Patrick sent me that. I don't know if you heard about that, Chris. Crazy. The fire department sending a cease and desist to their own city council. Do not build this here.
FDNY is going through, and I believe they've just passed their own code in regards to it, because these are popping up everywhere. They're on top of hospital roofs. They're in structures, as you've mentioned, Adam. They're just popping up all over the place, and there's no regulatory to control it.
It's true.
So sorry, Chris. You talk about the storage systems like Tom was asking, the exteriors. A lot of councils, a lot of first responders haven't taken into account of solar panels on residential homes who now have lithium-ion battery storage banks in your basement as a backup.
Yes, that's right.
So now, as us going into either basement fires, thinking it's a regular structure fire, this is critical for our 360s to notice where the meters are. Do they have solar panels on the roof? Now solar panels are integrated into shingles, so we can't physically see that 3-inch lift on a roof. So this is something we have to look at now.
And we've implemented down here in Gainesville, Florida, and that the requirement that they have to mark not only the battery packs and that for what type of batteries they have, but again, at the electrical panel and at the meter, that their secondary source, PV, tri-source, battery energy storage. So they're aware that there's 2 other sources of energy in that structure. Because again, Tesla power packs, all the rest of that are in garages, they're on the exterior of the house, they're in the basements. You just don't know where you're going to stumble on them.
Yeah, great questions.
Yeah, and throw into the fact too, you can backfill your power too, go charge your EV at work and come home and plug it into the house and power your house off of it.
And that's another thing they're selling. Yeah, you go in now, your battery energy storage, your photovoltaic, and you got your car chargers. Usually 2 of them, for a lot of the people down here are going electric.
Good questions here in the chat here. Randy said, did I just delete it? Yeah. County and city councils have no clear idea about the risks. They're told they're safe and that they love the commercial taxes. Yeah, we need to understand that I had a company from the US called Firehouse asking us to do awareness level training for a fire department in Northern Ontario because they didn't have anybody who could explain it. I guess maybe because they know I'm a simple first responder in layman's terms on how to deal with a lithium-ion battery event that might occur within this battery energy storage system, or even the risks. And I appreciated the call, right, for business. It was also interesting because I said, shouldn't you already have your own program in place and tactics and strategies to deal with a battery event in that community that you could provide the fire department in which you are installing it? And I'll be honest with you guys, the answer is no. Randy said it best in the chat. They have no clue, even the ones that are currently building them. Think about insurance companies, Tesla and other vehicle companies that are currently manufacturing these electric vehicles. There's nothing in complete documentation on the safest way to mitigate and suppress or deal with an event. It might talk about an emergency shutoff and having an isolation distance. So for example, up here in Canada, toxic gas, you're going to set it out for 100 meters or 330 feet. But what is that? Is that enough information for an insurance adjuster to come 2 days after a fire, or someone who's touching it with the incorrect or incompatible PPE? Maybe they're not wearing a mask. Maybe they're not wearing the correct amount of gloves. See, the metals from this smoke is so toxic and deadly that they're finding studies now that it's not coming out after 1 or 2 washes. Our extractors at the fire hall do not get our bunker gear warm enough in that high heat extraction wash to pull the metals out. That's scary. And that study came out from Teaks. Yeah, Julie.
Just wanted to put something that's been on my mind, but they really have to be careful. To me, this is like a Trojan horse. Depending on where they're coming from, they've caused nothing but, well, not nothing. I mean, it's not all for bad, but there's so many problems with these batteries. And you wonder, like you said, depending on where they're coming from, you almost have to wonder if there's I know you're going to think it's weird I'm saying this, but almost something sinister. Like you really have to wonder, because we've had so many problems with them. And it's not just fires, like you said, the chemicals, cancer causing agents and so forth. No, has anyone ever thought about that? I mean, it's kind of infiltrated now.
Try not to. Canada's in rough enough shape as it is. No, I'm kidding. But no, honestly, it's a good point. And remember, there are pros to this: high energy density, low cost, great for charging and recharging. I mean, there are reasons why we're using this. So we just need to understand that with these future considerations, provide more knowledge, experience, and training for us. And again, talking about the topics that we're going to get into right now: environmental concerns, toxic smoke hazards, fires and explosions. That's all right here in considerations. Here's our
Adam, to be concerned about is after the effect, in that you still have that hazard of contamination and finding the heavy metals within proximity of the actual fire. And again, going out, even your investigators potentially becoming contaminated from all of this material too. So
yeah. And Chris said it best. So when we're looking at the response, we're looking at the post-event issues. We have all these codes here on the screen. And again, I'm not going to sit here and bore you with a codes course. You can watch my buddy Chris Pfaff's fire investigation course for that. Just kidding. Shameless jab there. But the point is these codes don't teach response. Chris knows this. Justin knows this. Greg knows this. The codes are there as a regulatory body, but we as first responders, emergency managers, community and public safety officials have to read between the lines and put something together. And right now, and Greg can probably speak to this too, NFPA is 3 to 5 years from putting anything out in writing that says this is how said battery fire will be extinguished or suppressed or mitigated. So when you look at subject matter experts, like many people here, in this chat tonight, we have to make the best decisions we can from an incident command standpoint and mitigation standpoint to do what we can to keep ourselves safe as well as the public.
So on that note, Adam, but you go back one side on the codes, those are a minimum standard.
Great point.
They're not, best practice. Depending on your municipality and jurisdiction,
Yeah.
you could have like from being in the military, we had the National Fire Code.
Yeah.
So that goes across Canada and whatnot. But then you go into Ontario, they've taken the information from the National Fire Code, but enhanced it to make Ontario more, stringent. So every municipality, every jurisdiction is going to have a minimum standard, and design, installation, all these things are taking into account. Even looking at when we taught up north, that the one department they were building a lithium mine right beside the fire hall, and mutual aid. The closest mutual aid was 3 hours away. So looking at water supply,
Well,
manpower, it was unreal.
Greg and I
So-
taught a class last year at Omer. Again, shameless plug. Ontario Hazmat Responders Conference is in 2 weeks. Get your tickets. Greg's doing classes. I'm doing classes. But the class that Greg pretty much created it, and I co-taught, was airplane response for like your average volunteer fire department. Because think about it, just because you are a firefighter in an airport doesn't mean you're going to get that plane crash. It's going to happen in a community where you need awareness level training on the hazmat and the risks that happen, whether it lands in a field in your first in area as a volunteer, or your career department that doesn't even have an airport. We need some type of training to deal with that, some awareness level education. It's huge.
More likely rural than in a urban setting.
That's just it.
Most of your planes don't really crash on an airfield. They're either crashing on takeoff or landing. If
Yeah.
you've seen most of the things in the media recently, plane landing in in New York or New Jersey, on landing, taking off, the Delta in Toronto on landing. So all these plane incidents, they just don't happen on the airfield. They don't randomly, and most of it's falling out of the sky. And you have to also take into account, once that aircraft is on the ground, it's now a structure, not a plane anymore,
Yeah.
right?
Yeah.
So
Lots of things to consider, right? So what we'll do here is about 9 o'clock for the next 10 minutes or so. We're just going to do a scenario. Justin, you just want to break down, first off, tell us a bit about how that Decisolve AI platform you built creates these scenarios for training officers. And then we'll just run a battery scenario now. We'll listen to Greg's ideas, Chris's ideas, my ideas, and others, and Peter, and just go, how are we going to handle this? So do you want to just give a quick intro to what's going on here?
Yeah, thanks, Adam. So kind of the Coles notes of what we do here at Decisolve is we've engineered our outputs utilizing AI, but in a railed environment. So we control the training data. So we're looking at things like the NFPA. We are looking at things, certified papers and research that was done. We are looking in areas like Ontario here for the standards used, best practices, things recommended by the Ontario Fire Marshal. We have SOGs and SOPs from departments that are brought into our system as well to help create these scenarios and create them in environments that the people actually respond to. Right. So in today's scenario, we open it up, but created a couple kind of gotchas in terms of water usage, because that's always going to be a big problem when it comes to these fires and these situations we run into. And then also within the scenario, we'll throw in 3 scenario injects at timed events for certain events that are happening as things escalate in real time. So we'll get right into the dispatch. So we have our Station 4 responding to 1500 yard viewed road for a best unit fire in an industrial storage yard. We have occupants are unknown. Time of tone is 1342. So the description, what we're rolling in on, we have arrival at 1500 yard view road. We're seeing a battery energy storage system container. So our best container positioned on a gravel pad. And of course, they didn't listen to best practices or just anyone's smarts. They've positioned this between 2 light industrial units. So we can see thick dark gray smoke is issuing intermittently from the Alpha Bravo corner of our container, with a strong turbulent thermal plume visible above the unit. We are hearing popping noises. They are intermittent in and around the area of the container. We have a heat shimmer is apparent on the Bravo Charlie exterior of the adjacent unit. And the hazard, of course, is involving lithium-ion batteries within the container.
Nice. So I guess, Justin, I'm going to I'll get the ball rolling here, give a couple things I do right off the bat from isolation distances and other things. And then we're basically comparing this to what AI is telling us to do based on the NFPA standard, because your AI pulls from NFPA minimum standards, I believe, right?
Yeah, it pulls from those minimum standards and assigns that as questions to test responders or people coming to those events.
Cool. Amazing stuff. I think right off the bat, the isolation distance, we'll say 100 meters, if not more, because I want to use an air monitor to probably dictate a larger area where we create that hot zone. So for the non-firefighters here, a hot zone is basically an area where you should be wearing an air pack or not wearing an air pack and being back far enough. And we know that depending on the wind and other things, that's going to be a big consideration, where we're going to park our truck and how close we're going to get without an air pack. I'm a big fan of bringing an air monitor forward, maybe my thermal imaging camera to find out some hazmat geek stuff that many firefighters don't typically think to bring in for fires. What are your thoughts, Greg, maybe on moving forward with a TIC camera, air monitor? What other things go through your mind, kind of from a hazmat perspective?
So depending if it's we don't respond with our hazmat truck or trailer.
Good point.
Based, we know it's a battery. If we've done our PP or pre-plans, having colorimetric tubes with us with air monitors. The only problem with air monitoring now with these HF gas, it's super corrosive. You could kill your sensors.
Good point. We call that saturating the meters. Absolutely.
Yep. So now going down range with either air colorimetric tubes based on HF or whatever, we have another means of identifying. Based on the, you're looking at a very thick gray smoke. It's based on that printout. It's rocking. And if I'm already getting, if I'm already smelling cherry bubblegum, I'm one, too close. And two, I should be on air automatically if I'm that close. So I would be setting up based on water supply, master streams off my deck guns, off my trucks, starting to cool cooling the adjacent exposures, and start cooling that unit itself as well, based on the thick, dark gray smoke. You had really very turbulent thermal plume. That tells me right away it's super hot. It's burning really, really hot. So I'm also going to be looking at deflagration issues. So now getting into your initial isolation based on my explosion distances. So based on that, that's what I would be doing.
I like it. I like what Greg said. You know what? Let's get that power shut down. Let's get some water on this thing, okay? And again, mixed reviews on that. We throw in water, and just to let you know, from a firefighting standpoint, a little bit different, but same. I've been to more recycling and landfill fires in the last 6 months than I have in 14 years of being a firefighter, because of batteries and other junk that's catching fire in those piles. And you know what the chiefs ask us to do? Because we're the hazmat team? Yeah, Adam, you and your captain and crew, can you go around and bring these rubber mats, this is my friend Magneseal here, and start blocking off every sewer drain to make sure that the corrosive, toxic runoff does not go down into the sewer? Absolutely, Chief. We'll get right on that. Would have been nice if you told us that for the first 3 hours of the fire, because the road's already flooded and we can't even find the sewer drains now. But that's a good tactic, Chief. All joking aside, that's usually when they ask us to do that. So I guess from a tactical perspective, I'm playing devil's advocate. Is water runoff a concern? Sure, if you have the staff to deal with it like we do in Toronto, but probably not in a volunteer department where you need to focus on fighting the fire. You're not concerned about pHing the water around it, even if it's corrosive. Let the environment deal with it.
But even as a volunteer firefighter, there's probably more pesticides and runoff from farmers' fields than this itself, right?
So true.
We're going to need some big mats if we're going to stop the water from getting into ditches.
Well, especially if you've seen the farms that where Justin grew up. Look out.
Hey, guys. From a perspective of, I know you've identified that the occupants are not known, but let's assume this was a business or something where there's a safety person, or
Yeah.
you know, how should the those people be responding when they discover it, other than calling the fire department, obviously, but what else should they not be doing or should be doing?
Things that I think about is the ventilation system. So whether it's the building they're in, turning them on or turning them off. But I'm of the opinion to do either or getting the neighboring businesses to do that. From a health and safety perspective, ventilating toxic smoke or confining toxic smoke. And again, that's a whole other class in itself on, you know, fire dynamics and flow paths and all that is very important. Quick note here. City of Brampton, for example, they're permitted with their fire departments and their fire managers that they teach, the property managers, they allow them to actually touch the fire panel and turn on and off the HVAC systems to manipulate and control the smoke and HVAC systems in a building if there's a fire alarm, because they've been trained. In Toronto, they don't want us touching any of that. They don't want property managers touching that. They want maybe a building engineer, maybe a fire captain if they're comfortable, but we're even pulling back on those responsibilities. The reason I say that is because they're like, oh, well, our fire trucks have fans on them. Let's go and manipulate the building's smoke and fire issue with our fans that we have on our trucks instead of using the building system. So every AHJ or community is different, allowing those things. But from a health and safety standpoint, evacuating versus protect in place, ventilating versus non-ventilating, shutting down ignition sources, shutting down utilities. Do you know how many times on industrial sites I've done circles either in a fire truck or with a crew with a hose bundle on my shoulder and a flashlight, following the maintenance man who can't find the utility shut off because we have a fire and we got the gas still on and other utilities that are going to cause harm to us if they don't get shut off? Like, that needs to be their priority, in my opinion. What are your thoughts, Chris? What are you seeing differently? Obviously, you're a resident of Canada. It's been a while. What do you see as an issue with the property managers in the U.S. and Florida, other than most of them being retired?
The fact that, again, they don't know the systems that they got in the first place. And again, they're going to turn directly to the fire department and say, this is your show.
And Chris, you know as well as I do, for being in the fire service, the lack of training is very, very real. And that was the first course I ever developed eons ago when I used to teach at Durham College. My first class was called like Fire Safety Basics, and it was about teaching a firefighter, aspiring firefighter, how to reset a pull station and reset a fire alarm and look at a sprinkler system and a smoke versus a heat and understand what it's doing in a building. Because I knew right off the bat with my fire and life safety background coming in as a firefighter, the property managers were clueless. They had no idea.
That's all contracted out. That's all contracted out.
Scary.
And again, even in fire service and that, if it ain't your fire inspector and that, you know, there's some that, you know, have, you know, extended their education and are a little dangerous in that. But again, it's the SMEs.
Yeah. So to anybody here in the group, fire and life safety training is huge. You know, you have to understand those systems. Go ahead, Greg.
I got to take off, but thank you for the invite.
Good to see you, pal. We'll see you.
I'll see you next week. I'll see you next week.
Oh, right. See if you hear any convergence. That'll be great.
Yeah.
All right. Let's
See everyone. Cheers.
So again, we just have to have some type of a plan. What do you got there for an inject, Justin? What would be the next? Did we miss many things? Is there a couple things you want to mention?
No, I think we hit most of them there with dealing with the threat, and to Tom's point, from a building manager perspective, right? You have areas where you want people to go. If there's a fire, if there's an emergency, this is the meeting area, right? Having a conversation on a site visit with a fire department and say, hey, we've got a best facility here.
Yeah.
Is this location okay if we have a west wind? Are the people far enough away? Because you see smoke, you see fire, everybody stops, right? 15 minutes later, they're all hacking and coughing, wondering what's going on. Right? They are not far enough away. And having those site visits and figuring those things out, I mean, that's the best that what you can do for your people.
Tom, here's a quick story. When I was out in Eastern Ontario, the emergency shut off to disengage that battery energy storage system from the power grid, that transformer that was located beside the battery energy storage system, which was located right beside the big solar farm. The big e-stop, we'll call it, the big button, was 15 feet from the storage unit. If that storage unit was on fire, nobody's going near there. So when I said to them, I go, this is a fairly new unit. Do you have anything back at your military base or at your, like, let's say, your security guard kiosk or your guardhouse, for example? Is there shutoffs there to manage the power going to this battery energy storage system from a remote location? And their answer was, that's a good question. We should probably figure that out. Not only figure that out, but train everybody to know that that's an option. Because if not, you're going to get a bunch of firefighters like a crispy critter putting on their mask and trying to get as close to that button as they can or switch to shut it off. So we need to be smart about that. And you know, this is all learning for us, right? At the end of the day, as my buddy Bobby and Mike say, the hazmat guys, we're building the plane as we fly it. We're figuring this out as we go.
And you guys have mentioned this before. I mean, no one should be going near any of these gases or this fire without being on a tank, basically. And so anybody that would go to touch that button would be absolutely foolish. But they need to know that.
Never underestimate the incompetence of others, my friend, because you're not even a firefighter and you know that. You've been through my training before. Remember, I'm being honest, brother. 90% of firefighters do not know that this gas is more toxic than other gases. They might have heard a bit about it, but they don't truly understand that it's causing cancer at a rate of 200 times. They don't understand the metals are not coming out of the gear. They don't understand that the HF gas that's coming off of this is an acid gas. It's very corrosive and toxic. So while they think they might have an awareness level, they might actually take that risk that you mentioned and say, I'm just going to go in there for a short period of time. Heck, let's say they go in and they're wearing their gear properly, Tom. There's a fire department out in Durham region that came out after an industrial fire, took off all their gear after putting the wet stuff on the red stuff, and they had no idea that the water that they were putting on that particular product, it was a steel mill, was off-gassing and off-gassed into their gear. So when they took off their gear with their bare hands, they all got burns on their body and they all had to go to the hospital just from taking off their gear.
Yeah.
Who knows?
I think if there's one takeaway for this from anyone that's in industrial / dealing with batteries, stay away when it happens.
Yeah.
Okay, guys, who had 79 minutes in the pool? It was 79 minutes before Adam said put the wet stuff on the red stuff.
Now my buddy Joel Hendelman, he teaches ethanol. He says, put the white stuff on the red stuff because he's a foam guy.
There you go. I'll get him converted.
Exactly. I like it. No, I think it's good. I think that's about 20 after 9 now. I think we hit the nail on the head. And again, I just want to preface everybody. This is just the tip of the iceberg, right? Chris Gilbert could go on and on about some of the content that he's learned in these areas of dealing with batteries. Justin and some of the things that he's seen and others when it comes to just the different mitigation options that are available. Do they all work? Not necessarily. Some might even be snake oil. At the end of the day, we don't know unless you try it. You don't know unless you see the studies. You look at the research papers. You look at different things that can help make educated decision. And I feel personally that's all we can do at this point, right? Because of the amount of information coming out on dealing with these batteries and some of the great products that are available to us too. Chris, I know this is probably your first time jumping in on one of our online classes. We've known each other for a while. I like doing this because we can keep in touch and I don't have to spend $1,500 on a flight to come see you, you know?
Hey, more than that now that the fuel price gone up.
Oh my gosh, I forgot about that. But no, it's good. What there you go. Share the window. Anything that you took from tonight, Chris, just from popping in and kind of getting a bird's eye view chat with a bunch of fellow Canadians again?
Yeah, I think you're in the same boat as everywhere else in the world, including all of the U.S., where it's still a learning curve, and again, there's so much that we don't know, and the lack of training and information.
That's the truth. Very, very true.
Huge hurdle.
Yep. No, it is. I guess right now. So again, if anybody has any questions, my computer's all screwed up here. Was the chat? So again, if you have anything else further that you want to ask about or follow up on, please reach out. I mean, as part of the Mitigation Alliance, this is why we're here. This this network where we can, you know, review different ideas and different things to hopefully help you. So whether you're an emergency manager, firefighter, you know, town council, even someone that's involved in infrastructure and planning, hopefully we can put some of this information together for you to assist you. Because with this topic, in my opinion, we're getting calls from a little bit of everybody when it comes to this. How's it going, Randy?
Great.
Good,
Really
brother.
good session. Thank you very much. For those of you who don't know me, I'm past president of the Alberta Fire Chiefs Association and
Nice.
fire chief with Lac-Saint-Anne County, which is just northwest of Edmonton, Alberta.
Great.
And my question is the proliferation of these systems near urban environments due to a lack of regulation?
Mm-hmm.
Is that what's happening, like in North America? Like it's because they seem to be put where it's convenient, and so we have a pretty major development happening. And I'll talk, you know, certainly, you know, thank you very much, Adam, because at the end of the day, I mean, they're just putting them where there's access to power lines, access to grids, and you know, so that they can feed them, and you know, that kind of thing. And all of this area, it's always in the middle of a town or on the edge of a town. And so as fire chief, and we're not even an accredited municipality, so the province handles our code accreditation. I'm being asked, and of course I sat through a presentation where I was, you know, like this, our councils, this is safe, this is safe, this is safe, you know, low risk, high reward. And I'm going, not from any session that I've ever attended. Is that the truth?
Yeah.
So I think,
and we're
go ahead, Tom.
And we're seeing this all over the map. Is like somebody on council says, hey, there's jobs, and somebody's got the money to invest, and it's for a small town that's lost jobs, it's like, well, this will be an answer. But it's often a quick response, and then there's then the fire department finds out after the fact that this has been approved, and did you go through the checklist and all these things? And the answer is it's not happening enough. Let's put it that way. And these horror shows are going on all the time. So
I'm certainly interested in determining what we can do as an industry to at least get the more consistent information to our councils. That's what I'm hopeful.
Chris, what are you doing in the U.S.? Like, obviously that's a bit above our pay grade, but like I'm seeing here in Ontario, just to give you a heads up, like I'm seeing just councils vote based on a couple of subject matter experts, depending if they're pro or con with the BESS system, and making that decision without the engineering side from what I've seen. Like, is there an engineering code, for example, in the state that you know of in Florida that says a battery energy storage system needs to be this far from said building and this type of infrastructure? I haven't seen any hard facts on that myself.
The electrical code's trying to catch up in that, but you know, NFPA 855 is the most solid of distances and where you can, you know, position in that. But again, your small rural communities like we have here, where Duke Energy dropped their 2 megawatt unit in that, and it's sandwiched between a veterinary clinic and a residential structure with an 84-year-old you know, resident. And of course, I didn't find out about it until they were actually installing batteries. I'm going like, wait a minute, you failed to meet, you know, some of our hazmat regulations,
right?
And you're catching up after the fact, because again, it's going to go where the electrical power company prefers it to go, because it's the best for them, and the heck with everybody else. And that's the problem, is we're basically catching up and trying to catch these as they're dropping in, and they're going everywhere.
And I would add the plug that I think the different groups should be bringing in Adam to talk, because he's going around North America learning from folks, and he's as big an expert on this topic as anybody. And you know, when they bring in an expert, they should be bringing Adam in and have him in, or doing some training. You know, even lunch and learns that he can do are great. So,
and I'll send you, Adam, the information I got for our Duke Energy one, and the safety standards that we force them to implement into the system. Everything from 1 PSI roof panels that pop to alleviate the buildup of pressure and that for explosion and deflagration, that to outside the panel fire access and that for everything to do with the system, from standpipe to triggering the internal fire suppression systems.
Yeah, there's just so many variables.
Yeah.
No, I get it, and that's why we have to have these conversations. I mean, really, and putting the right things together. I could put you in touch, Randy, with a few other people that might have a little bit more of a technical expertise to give hard facts and numbers. But as far as I'm concerned, I believe the authority having jurisdiction in that particular area. You know, same with firefighter training. One municipality might do something different than others, even though we have an NFPA standard. They just make their decision and go with it. I feel it's very similar with these batteries. So what we'll do here, guys, again, if you have any further questions, please feel free to reach out to us. Follow us on social media, Fire Mitigation Alliance on LinkedIn, Tom Hawkett, of course, Justin, Peter, myself, from Instagram to Twitter, LinkedIn, all that stuff, because it's a good way to keep in touch and have these questions answered. And hopefully we'll talk about other topics in the future. So other topics we talked about in the past was dealing with wildland events, of course, electric vehicles, battery energy storage systems, hazardous materials in the community. We did one on industrial fires just last year. So the next few months, you'll see us do another one virtually. And then we'll probably do one this June or July in person in Mississauga. So again, hopefully for those that are local, you'll be able to make that too. Anything, Tom, before we sign off?
No, just thanks. This is a great session, very interactive. That's why we do these.
Also, we recorded it, so it will be on the fire mitigation website afterwards too. So when I send a thank you email out to everybody, we'll get Tom to give me that link, and we'll send you the recording if you want to look at anything again. But thank you so much, everybody. We appreciate it, and let's all keep in touch. Thanks, everyone.
Cheers.
Stay safe.
Hey, guys.
Thanks.
Good to see you,
Good night,
Chris. Good
everybody.
to see you guys.
Yes, sir.
Bye-bye.